welcome to my second video about lungs, and today we're going to be looking at a spirometer trace and we're going to be calculating minute ventilation. So a spirometer is a machine that we can use to measure the different lung capacities that someone might have. And so the first value that you really should be aware of is the tidal volume that's showed on your spirometer trace here, so this distance between these two lines here. And it's essentially the normal, or it's the volume of gas that you move in and out of your lungs through normal breathing. So as we sit here now, breathing normally, then that will represent your tidal volume. So again, it's specifically the amount of air you either take in or breathe out on a normal breath. And so it's usually measured in roughly around 500 millilitres in terms of its volume, or 500 centimetres cubed, because they're relative equivalents. Now the next one is your inspiratory reserve volume. So as you breathe normally, if you then take in a sharp intake of breath and then hold it, that will be your inspiratory reserve volume. So the maximum amount that you can take in above your tidal volume. If you then exhale normally, so you go back to a normal breathing pattern and then try to exhale fully and then hold that, that's called your expiratory reserve volume. So that's the maximum volume of air that you can breathe out past your tidal volume. If you were to add up both your expiratory reserve volume, your inspiratory reserve volume and your tidal volume, you'd be able to calculate something called your vital capacity. And so that's the total amount of air that you could breathe in or out of your lungs. And so your vital capacity is the maximum amount of air that you can exhale after the maximum amount of air that you've inhaled. And so it's the IRV plus the ERV plus your tidal volume. Now your residual volume, or your RV, which is this value here, that's the amount of air left inside your lungs after the maximum exhalation. And so that usually, I think it's roughly between 600 to 700 millilitres or centimetre cubed. And it stops essentially it stops the lung from collapsing. And so you always have some air within the lung. And so here are some of the exact definitions for some of the different types of lung volumes. So you have tidal volume, inspiratory reserve volume, expiratory reserve volume, inspiratory capacity, which we haven't discussed, but it doesn't come up in the spec, your vital capacity and your residual volume. So what we're going to look at next is minute ventilation. So your minute ventilation is the amount of air moved in or out of the lungs per minute, and so it's your tidal volume multiplied by your breathing rate. And your tidal volume is either usually in millilitres, sometimes centimetre cubed, and the breathing rates in breaths per minute. And so what you'd expect from someone exercising is you'd expect not only a greater tidal volume, because that's breathing more deeply, and you'd also expect a higher breathing rate. So if we have a look at the graph for minute ventilation, look at this graph here. So you have time along the x-axis and you have the lung volume here, and so we can calculate the tidal volume here as being 500 millilitres, because the difference between 2,500 and 3,000 is 500, and so it's 500 mil. And if we look at the number of breaths, so each breath takes 5 seconds. So that would be, for instance, you could see the lung volume here, that's going down, so that would be breathing out, and then the lung volume going up and therefore breathing in, and so that entire breath takes 5 seconds, and therefore your minute ventilation at this point would be, there'd be 12 breaths per minute, so it would be 12 multiplied by 500, and therefore you'd end up with 6,000 millilitres per minute. You could probably cancel that down to 6 litres per minute if you prefer. How this would vary for someone that was exercising, you'd expect the tidal volume to be greater, and so the height of this trace would be greater, so it would be taller, and also the points would be closer together because you'd be breathing quicker, and hence your breathing rate would go up. If you join me on the next video, we'll be looking at diffusion and dissociation curves.